All right, hello everyone. Hopefully you're having a beautiful day. And today we're going to solve LeetCode 543, diameter of binary tree. Given a root of a binary tree, return the length of the diameter of the tree. A possible diameter of a binary tree is the length of the longest path between any two nodes in the tree. The path may or may not pass through the root. The length of the path between two nodes is represented by a number of edges between them. So if we have this first example here, what is the longest path between any two nodes? It would be either from 4 to 3 or 5 to 3. If we went from 4 to 2 to 1 to 3, how many edges is that? This would be the first edge, the second edge, and the third edge. Or if we went from 5 to 3, this would be the first edge, second edge, third edge. So the diameter of this tree is 3, because the longest path between any two nodes. But the problem statement says that it may or may not pass through the root. In this example, it does, but in many other examples, it might not. So what we're going to have to do is calculate the amount of edges on the left subtree and the right subtree of every subtree, add them together because that could be a possible path. All right. So just to go over what our algorithm would be, we're going to do a depth first search on the left and right subtrees of every node, and we're going to count the number of edges that we find. At this point, we add them together and compare it to res because this could be a possible answer. And then we have to return up to the parent, but we won't return up the accumulation of the left and right. We return up the maximum because we only get to go down one path. Let's say we're at the 2 and there's one edge on this side, one edge on this side. And what should we return up to the node 1? It would be 1 plus 1 because we have to take the maximum of 1 and 1. So either one of these plus, or the edge that connects it to the 1. If we took both, this would be 2 plus the edge that connects it to the parent, 1. We can't return 3 because that would be like us going to 5 to 2 to 4 and then back up to 1. This is not a valid path. That's why we have to pick the maximum of the left and right, and we cannot choose both. And that is the main tricky part of this problem. All right, so let's go into the approach. So we do DFS, node.left, node.left, and since this is a recursive function, we finally hit our base case. And if we hit a null pointer, then what we want to do is return up 0 because there's no edges along that subtree. From the left subtree of 4, there are no edges, so we want to return up 0. The right subtree has a very similar story, return up 0. And from this point, let's say this, we have to check if this is a possible answer. We say the left plus the right is 0. We compare that to res, which starts off at 0, which is our global variable. It's going to hold what is the max diameter we found thus far. There's no change because 0 and 0 are equal. So we continue. So what does 4 return up to its parent? The max of 0 and 0 is 0, and then plus 1 for the edge that connects it to the parent. So that would be a 1 here. Now from the 2, we go to the right subtree. A very similar story. We go to the left, we hit the null pointer, return up 0. Go to the right, return up 0, and we return the max of the left and right plus 1 for the edge that connects to the parent. So 1. All right. And now we're at the 2. We pause and say, hey, this could be a possible answer because what if the diameter doesn't pass through the root? All right, so what's the left plus the right subtree? It would be 2 because the left has one edge, the right has one edge, and we compare that to res. Res is at 0, so we can reassign res to be 2 instead of 0 because we found a greater diameter. All right, so what does 2 return up to its parent? We're going to get the maximum of the left and right subtrees. So in this case, it would be 1 plus the edge that connects it to the parent. So 1 plus 1 is 2. Now we go to the right subtree of 1. Very similar story. We hit the null pointer, return up 0. Hit the null pointer, return up 0. And now we return up, well, the left and right subtree has 0 and 0. 0 is not greater than 2, so res does not get updated. And we return up 1 to the parent because 0 plus the edge that connects it to its parent is 1. So we get a 1 here. Now finally, we're at 1. And now we compare, hey, have we found a path that's greater than res? Our left subtree has 2. Our right subtree has 1. 2 plus 1 is 3. So that means that we found a greater diameter. So we can cross out the 2 and have the 3. We have traversed the tree fully and there are no more nodes. So now we just return res. All right. So hopefully that makes sense. And the main point that we really have to hammer in is that the diameter may not pass through the root. So every node, we have to check if that's a possible answer. That's why we have the global variable res, and we do not just return what DFS returns, right? If you understand that, then this question is quite trivial. All right, so let's go into the solution. I like to always handle edge cases first. Let's say they gave us a binary tree with no nodes. So we say if not root, return none. All right, next we want to create our res variable, just our global counter that will store the maximum diameter we found thus far. And now it's time to create our diff or search function. So we define a function DFS, and it's going to take in a node. Now, since it's a recursive function, we need to have a base case. So if not node, return 0. If we hit a null pointer, if it's not truthy, return 0. Just like when we were at the 4, when we went to the left hand side, we return up 0 because there's no edges on the left hand side of 4. All right. Next, what we want to do is actually first, since we're going to be using the variable res inside the DFS, we need to call non-local on res. So we can update res within this DFS function. All right. So now we need to calculate how many edges are in the left and right subtrees. So we can make a variable called left, and that's going to be set to DFS of node dot left. And we do the same thing for the right. So right is equal to DFS of node dot right. All right. So now that we have variables that hold how many edges we found along the left and right subtrees, we need to update res to see if we found anything better. So res equals the max of left plus right or res. So if left plus right is greater than res, it'll be updated, and if not, we'll keep res the same. So that handles if the diameter does not pass through the root. So now, what do we return up to the parent? Let's go back to the diagram. Let's say we're at this node here, 2. We found that the left has one edge, the right has one edge, and we need to pass up not both edges, but whichever one is greater. So the max of left and right plus 1 for the edge that's connecting it to the parent. So we return the max of left and right plus 1. All right. And now all we have to do is call DFS. So we say DFS on the root and return res. All right, so let's run it and see how it goes. And there we go. We solved the problem, and it's very efficient. So if you have any questions, please comment down below. Peace.